722, which is titled Coordinate Geometry and Midpoints. Okay, this word midpoint is two words stuck together. What two words are there? Middle point, right? All right, so the question we're going to answer today is, how can I find a midpoint? Question 793 says triangle mid segments. So we've got mid again, all right? As Sergio was analyzing polygons, he drew a line segment that connects the midpoint of two sides of a triangle. This is called the mid segment of a triangle. I wonder what we can find out about this mid segment, he said to his team. Examine the drawing below, where DE is the mid segment of triangle ABC. So the triangle's on the outside. Here's triangle ABC. And this segment from the midpoint here to the midpoint here is called the mid segment. All right? How do you think DE is related to AC? How do you think this DE is related to AC? Anybody have a good guess? Educated guess? Yes, sir. They both have the same what? Angles? Okay, yes, they are going to have that. Yes? What's congruent? This piece and this piece? The ones that are marked congruent? Yes, but they want you to say, what do you think about DE and AC? What do you think about this segment DE in relation to segment AC? Lee. They look very parallel, right? Okay. How do their lengths seem to be related? What do you think about the length of DE in comparison to the length of AC? AC is larger. Yes, it clearly is larger. Anybody want to guess by how much? Yeah, sure. Yeah.
2.
Okay. So what do you mean by 2? 2 more inches or times 2? Possibly. Okay, so here's what we're going to write. We're going to say that AC and DE, they appear to be parallel, right? And it looks like DE is going to be half of AC. He said it the other direction. He said that AC was 2 times DE. Half and twice are inverse operations, right? Okay. Question 794 says, Cassie was looking at the triangles in problem 93. She thinks that 2 times DE is equal to AC, and AC is parallel to DE. She tells Sergio that she can test her ideas about the triangle midsegment using a coordinate grid. She started with triangle ABC, with the coordinates of A, B, and C at these locations. So we're going to first graph those 3 points, okay? So here's point A at 0, 0. So right at the origin, you're going to put a point and label it A. B is at 2, 6. That means go 2 to the right, up 6, put a point, label it B as in boy. Point C is at 7, 0. That means go 7 to the right, put a point, and label it C as in cat. Okay? After you've graphed the triangle, part B says, with your team, determine the coordinates of point D at the midpoint of segment AB. So midpoint is going to be halfway from 1 to 2 and halfway from 0 to 6. What's halfway from 1 to 2? How about 1? Right? Halfway between 0 and 2 is 1. Okay? And then what's halfway from 0 to 6? 3. So you should have a point right here, D, and that point D should be at 1, 3, right? So D is going to be at 1, 3, put a point, label it D. Then you're going to determine the coordinates of point E. So E should be halfway between 2 and 7. Ooh, that one's a little bit harder, right? What's halfway between 2 and 7? 4.5. Mm-hmm. And then going up, what's halfway between 0 and 6? We already said that on the last one, right? It's at 3. So your midpoint should be at point E, which is at 4. I called it 4.5. She called it 4.5. We're same thing, right? And at 3. So at 4.5, 3, put a point and label it E as an elephant. All right? Question C says, what is the relationship between the lengths of the midsegment DE and the side AC? It's a little bit easier to see now that it's on a coordinate plane than when it's just drawn floating in space. Yeah. So we're going to say that the length of DE is 3.5 units. You can simply count it. 1, 2, 3.5. And the length of AC is 1, 2, 3, 4, 5, 6, 7 units. What do you notice about these two numbers? Dustin. Yeah, DE is half of AC. What if you go to the other direction? 7 is what to 3.5? Double or twice. So it depends what direction you're going. You're either going to say half or you're going to say double. Okay? All right. Calculate the perimeter of triangle ABC and the perimeter of triangle DBE. We're going to, they didn't leave us enough room to do the Pythagorean theorem for each of those. So I'm just giving you the answer for triangle ABC, and it's a decimal. So you're going to do the wavy equal sign. And the perimeter for DBE, again, they didn't give us enough room. These two numbers are half. So the larger triangle would be double. The smaller triangle is half, depending which direction you're going. Okay? Part E says, calculate and compare the area of triangle ABC and the area of DBE. That's a little bit easier. To calculate the area for triangle ABC, you can simply make it into a rectangle first. So that would be 6 units this way, 7 units that way. So 6 times 7 is 42. Half of 42 is 21 units. Then to calculate the area of the smaller triangle, it's 3.5 units this way and 3 units this way. And then half of that is 5.25. So the areas in relation to each other, they're not half, they're 1/4. A little bit trickier. So perimeters are half, areas are 1/4. All right, I'm going to move this up. You'll see it in just a second. All right, question 95 at the top of page 22 says, as Cassie and Sergio worked on problem 94, their teammate Esther had difficulty finding the midpoint of BC. The team decided to look for another way to find the midpoint of a line segment. To help Cassie draw AM with A at 3,4 and M at an 8,11 on graph paper, then extend the line segment to a point B so that M is the midpoint of AB. Justify your location geometrically or algebraically. Okay? So the first point they want you to graph is at 3,4. That means go 3 to the right, up 4, put a point, and label it A. 3 to the right, up 4, put a point, and label it A. For M, the point is at 8,11. That means go 8 to the right, up 11, put a point, label it M. Okay? That point is going to be the midpoint, not the end point, the midpoint. So this is only half of what the ultimate segment is going to be. So we need to find the other endpoint. One way to figure it out is to use the slope, right? I can go from A to M, and if it's the midpoint, it's going to be exactly the same from M to the other endpoint B. So I simply count it up 1, 2, 3, 4, 5, 6, 7. Then I counted over 1, 2, 3, 4, 5. Oh, did I write it backwards? I did. I wrote 7 over 5 over 7. Up 7 over 5. So you're going to do the same thing to get from M to B. You're going to go up 1, 2, 3, 4, 5, 6, 7, and over 1, 2, 3, 4, 5. So you should be up 7 over 5, up 7 over 5. If you do the same slope from here to here as you do here to here, that's going to make B your other endpoint. Okay? Question B says, Esther thinks she understands how to find the midpoint of a segment on a graph. I always look for the middle of the line segment, but what should I do for the coordinates if the coordinates are not easy to graph, she asked. With your team, find the midpoint of KL if K is at 2 and 125. How'd you like to have a graph where you had to count all the way up to 125? That's kind of a really large number to fit on a coordinate plane, right? I mean, if you were in Desmos, you could shrink it or make it bigger or whatever. But if you're just on a piece of paper, either it's going to have to be small or you're going to need a big piece of paper, okay? The other endpoint L is at 98. How'd you like to count over to 98? And then 15, okay? So let's pretend we don't have graph paper. Now we need to figure out a way to figure out what would be that midpoint. How can we get the midpoint of KL without using a graph? Anybody know? We want the middle number, yes. Okay. Sort of. You actually want to find the average, the number that's in the middle, right? So you're going to take the 2 and the 98, and you're going to add them together. The 2 and the 98 is going to get you 100, and then you have to divide it by 2. So you're going to end up at 50. Then you're going to do the same thing for the y's. So you're going to take the 125 and the 15, add those two together, and divide by 2. So 125 plus 15 is 140. Divide that by 2 to get to 70. And the last question, question C, says test your team's method by determining the midpoint of the segment with endpoints -5, 7 and 9, 4. And then check your answers with your teacher. So on your own, I want you to do this last one, and then I'm going to come around and check your answer.